Okay, move to question 12. So here, a helicopter can hover in a fixed position as shown. Fixed position in sense, this helicopter is now standing stationary. So that means the net force acting on this helicopter is equal to 0. And that is the reason why it is, standing or hovering in the fixed position, correct? We will continue reading. The helicopter blades move air vertically downwards. So here, during this hovering process, what this blade is doing? Moving air vertically downwards. Explain how this enables the helicopter to maintain a constant height above the ground. So constant height above the ground means the helicopter is actually remaining stationary because it is in the fixed position, correct? So how will you answer this question? To answer this question, we should take the idea from Newton's first law, second law, and third law. Okay, so we will start with the Newton's third law. What is Newton's third law? Every reaction, there is a equal and opposite reaction. So here, what is the action here? So if I'm drawing the free body diagram, because it's a 4-mark question, so we should answer this question in that level. Okay, so what we can say is, so in this question, how to answer this question? So here, this is our helicopter. My drawing is very bad, forget about that. So just consider this is for your information, right? So this is our helicopter. What this helicopter is doing, this especially the blades of this helicopter is actually pushing air downwards. Okay, so the force that is acting, the pushing air, that force is actually acting downwards. So due to that, what happens according to Newton's third law, if this is actually the action. Okay, so this is our action. So every action, there is a equal and opposite reaction. So this is our reaction. So now here we now got an idea that if there is an action, definitely there is a reaction, correct? So this reaction is actually acting upwards. There is no doubt in that, right? So this is our helicopter, and this reaction force is actually acting upwards. The reaction force is actually acting upwards, and this particular helicopter has its own weight. So the weight is actually acting what? Downwards. The weight of this is actually downwards. Yes, we have two forces with us. One is its weight and one is its reaction. So don't confuse with the downward air force, because the downward air force is actually the responsible thing for this particular reaction. So now we already considered that. So the reaction and weight is actually acting, reaction is actually acting upwards, and the weight is actually acting downwards. Am I right, my dear students? So what we can do is, we need to answer in such a way that why this is maintaining a constant height. That is what we need to answer, right? So why it is maintaining a constant height? The helicopter is actually standing in the stable position or equilibrium position. Why this equilibrium position is happening? According to Newton's second law, force, the external unbalanced force is equal to mass into acceleration. So if no external unbalanced force is there, then there is no acceleration. So that means that particle remains in the stable position, correct? So here, why it is not moving? Because the weight of the body is exactly balanced by the reaction. That is the point we should include here. So weight of this helicopter is exactly equal to the reaction force. Therefore, the net force is equal to, how will you find the net force? Weight minus reaction, that is equal to 0. So that means weight is exactly equal to reaction, correct? So net force is equal to what? 0. Therefore, there is no acceleration, correct? There is no acceleration. So that is the reason why it is maintaining a constant height, correct? So what all points we should include here? What all points we should include? So I'm just rubbing all these things because I just want to include the points the examiner is actually interested to see the valid points. So what all points we can include here? The first point we can include here is the blade exerts a downward force on air. Okay, blade exerts a downward force on air. This is already given in our question. So what? According to Newton's third law, there is equal and opposite reaction. Opposite reaction or to get a clarity, opposite force. That is actually the correct word. There is an equal and opposite force acting on helicopter. Acting on a helicopter. And now, what this opposite force will help? So that is the second point we will be elaborating. Opposite force, or in a bracket we can say the upward force, correct? Upward force balances the weight of the helicopter. Balances the weight of the helicopter. So what? Opposite forces balance the weight of the helicopter. Then, according to Newton's second law, if no net force acting on the helicopter, no acceleration for the sigma. Bracket, if you want, you can note it down this. F is equal to ma, correct? You have F is equal to 0, therefore definitely acceleration is equal to 0. Hence, helicopter maintains a constant height. And if you want, you can note it, you can draw a small free body diagram. Like this is our helicopter. This is the air force acting on air by the blade. As a result, a resultant or upward, not resultant, I mean the opposite force, the reaction is acting on helicopter, and the weight of the helicopter is actually acting downwards. Therefore, no net force, correct? This is the idea. Okay, so 4 marks. So 3 valid points will help us to bag this 4 marks.